So the advanced channel is finished, and now we can look at the method to review it. So what I have here is the reviewer's checklist for 2022. We might make some edits to this because just see if there's anything new that needs to be added to it. But it has some ideas on how to look at channels and how to review channels. So let's start with the first one. So it says, was the criteria used to model the 1D channels in the chan.dat properly documented? So no, I didn't document anything. Just for this purpose, I just ran the channel. I mean, actually, I guess the process is documented because it's in the tutorial. So I guess we could change that to yes. And are the channel inflow and outflow node locations assigned appropriately if used? We didn't get an error message that they weren't there. And if we look at the data file, we can see that it's not assigned to the user channel. It's assigned to the left bank, center node of the left bank, and the outflow is assigned to the whole cross section. So that, and the outflow is set to number 3, which means floodplain and bank. So that is the correct way to set up an outflow node for this channel. So we'll go with yes. Are the channel cross sections defined properly in the chan.dat and the exeg.dat? Are the cross section roughness values and the channel lengths assigned correctly? Are tributaries properly modeled? So no tributaries. And if you wanted to review the cross section data, let's see what we got here. N value. Let's try this one. Nope, that's the cross section XY data. Well, let's see the N. Oh, here, it's probably here. I already looked in that. Well, the N value data is back in this line. I don't know what table it goes to. So we set this. If you want to do that, you can see that there's no change in N value. They're all set to a uniform N value. If you wanted to give it something a little bit different, like maybe bump it up down here where it goes natural, or maybe make it a little bit lower up here, more something composite between a rectangular, or I mean a Gabian rough banks and the concrete bottom, then that would be appropriate if you wanted to do something like that. But other than that, I'm just going to leave it as is and maybe see if I can change it like 20% up and down and see if it makes a huge difference in what's happening in the channel. That would be something you could test. So we'll just put yes. Did you review the channel bed slope in the profiles? Are there any spikes that need to be addressed? So what we'll do there, instead of opening it in profiles, we will open it in, first of all, let me go back here to the cross-section editor and import the HiChan.out. And then I'll use this tool right here to plot the profile. And then we can just close this table and that will make it. So you can see that there's no spikes in the profile, nothing weird going on, looks pretty good. And then one more. And it's pretty uniform channel, so no problems with it right there. It looks good. The banks look good. So on that, we can say yes. And then if you wanted to use Profiles Program, you could go to the Profiles Program. And what you'd want to do here, we already looked at the profile. So what you'd want to do here is view bed segment slope, and then maybe view local reach, and then maybe grab the top one, and then come here. And I hit view the cross-section data, and then just start looking at every single cross-section. And what are we looking for? Are they changing? Are the geometries weird? Are the interpolated cross-sections weird? Is there anything going on with these cross-sections? And just check every single one, make sure that they're all valid. Now we're into segment 2. Cross-section 4 and segment 2, cross-section 5, cross section 6, and now cross section 3. And you can see that everything transitions really well. There's nothing major. Cross section 4, and I think there's 9 in this one, 5, 6, and then things are, whoops, sorry. And things are getting a little more of a transitional issues down in this area where things get a little bit funny, but it still looks really clean. And that's it. That's the last cross section. So those all look good. So I'm going to go ahead and give that a yes. Are the right banks assigned properly for a given channel? We put a lot of work into the right banks, and we can review them just quickly, just to make sure that they look clean, that there's nothing totally in the wrong location. Like that one's okay. It could be up there, but it's okay. It's just fine right there. What happens to the banks is that the grid element elevation is reset to the bank elevation when the channel runs. So you don't have to worry if they're not perfectly aligned to the bank, because it'll bring it up. It'll bring the grid element elevation up. And you can see that we don't have any problems. Maybe that one right there is even fine. That's not, because what's going to happen when this runs is that this grid element, the elevation of this grid element is going to be reset to the elevation of the bank right here. Also, if you wanted to review that bank right there, you could hit this button right here and then just grab that cross section, and it'll give you the station elevation points right here. So you can see that 1389 on the left, or on the right, 1391 on the left. There's nothing wrong with that. That's perfectly fine. Okay, let's see what else we have here. No, let's go back here to the questionnaire. Yes, the right banks are good. Is there a efficient number of cross section to count for all the bends in geometry? Yes, we put a lot of time and effort into that, making sure we got our transitions and all that. So that's a yes. Are the prismatic channels, okay, they're not used, so let's say NA. Not applicable. Are there any 1D modeled using only grids? Yes, that should be one channels. No, I don't think so. I think everything in here in that system that should be modeled as a channel is modeled as a channel. Are the channel transitions from floodplain to channel? We don't have any channel transitions, so that's not applicable. We are transitioning. We are going straight to the edge of the channel, and there is no transition onto the floodplain. CH volume dot out. I'm going to check that real quick just to make sure that that is okay. So let's just go CH. And what we're looking for is to make sure that this doesn't get filled up with numbers, and that looks fine. If this gets over like 0.001, then you have a volume conservation error in your channel, and this one's fine. So that one is a okay. No VC error. Okay, spot check the channel hydrographs upstream and downstream. Does the flow propagate downstream? Are there any significant loss in discharge downstream? Does the hydrograph show any instabilities? Okay, let's check this one out real quick. First of all, I'll close the profiles program, and then I will open up the hydrog program, and we will plot the channel hydrographs. And you just start at the first cell, and you just go downstream and see how that propagates downstream. And you can check every single one, or you can spot check them. You can check a few at the top and a few at the bottom. Like if I return to list, I can go to a few in the middle, and they look fine. Return to list, go to a few at the end, and they also look fine. Another peak coming in, a little bit of rainfall coming in from somewhere. That's not a spike. Okay. And we're probably into the other channel now. Whoops. So let's go to, and maybe start up here. Yeah, we've already seen that. Okay, return to list. Still looking good. Return to list. And we'll just go 1, 2, 3, 4. Okay, that's a little bit of something right there, but I don't think it's anything that I'm concerned about. It still looks real, like real flow, not like, and this is downstream of the structure into the next load. So return to list, we're now here, and we were about at 12. So let's go ahead and let's return to the list. Come down here and just look at the last few. And I don't see, whoops, sorry. If you get going too fast on that, you will close it. Okay. But yeah, no problems there. Last grid element right there. And then the last grid element doesn't have any flow because it's an outflow node. So that's a sink. So that one's fine. So okay. All no hydrographs look valid. Okay. Is there any unreasonably high velocities? Let's go ahead and check that out. So if we go to vel time FP or vel time C, vel times C dot out. What we're looking for is anything over 6 feet per second or anything over like 10 feet per second or anything unrealistic. So you could even do like an overland channel calculator, and that would tell you what velocity to expect for the given slope and dimensions of the channel. Another thing we're looking at, when are these flows peaking? They should all be peaking around the peak discharge of the rainfall or the peak discharge of the hydrograph. They should all be around there. Some of them are a little early, so that's probably some noise, but it's so close to this value that I wouldn't really worry about it. Also, this list is not sorted by grid element. This list is sorted by velocity. So you're really looking, this isn't a good way to look at this is not a really good way to look at the propagation. It's just sorted by velocity, not by time and not by space. So anything above 10, I would be concerned about. All right, what's next? So this is okay. And then all of them are below 7 feet per second. Okay, time step decrements. So we look at the time dot out. Whoops, sorry, I need to just close that, so I'll stop opening it. We have channel element 32169, which has a good number of time step decrements. Let's go ahead and take a look at that and see if there's anything weird about it. I'm assuming it's the inflow node. What was that, 33169 or 23169? 2332. No. That's the number. It's this one. Let's just copy it. Copy that and paste that in here. And oh, nope, that's odd. That is not a, that is most definitely not a, let's see if there's anything weird about that. So 32169, first of all, let's put it in here. Okay, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. Doesn't look bad there. The end value. I know the profile looks fine. We already reviewed every profile. How about the end value? Okay, it does have a 30 foot length, so that could see it's surrounded by 36 foot length, so that could cause some issues. You could bump that up a little bit and take these and shave these off a little bit, but I'll probably that would just move the time thing somewhere else, so I'll just ignore it. It could also be its relationship to the grid. Let's see. Yeah, I don't think that you're going to fix that so I think we'll just leave that because There wasn't anything wrong with it, so let's just leave it alone and let it adjust the time step. The channel is going to adjust the time step somewhere to your minimum time step. So sometimes when you fix one, or like increase the end value, or maybe change the slope a little bit, or maybe change the length a little bit, anytime you do something like that, you're just going to push the error somewhere, or push the time step decrement somewhere else in a channel. So unless it's really bad, or there's actually something wrong with the grid element that's causing the channel to slow down, just leave it alone. Okay, so let's first of all, we'll put this in here. Was listed 2332 times. So no edits required for that one. Let's just say okay. Did the consultant check to make sure all of the channel interior nodes were incorporated in the channel interior nodes.out, just performing the spot checks. So let's take a look at that file, channel interior node.out. I think it's just like a list of grid elements. So what you could do is I suppose you could plot these grid elements on QGIS and review them. And maybe if this was a district project or a project with a really complicated channel, I might be concerned about that. But since there's no tributaries, there's no weird, the channel doesn't have any weird changes in the bank. The left and right banks are very uniform and very normal. Like there's not major spaces in between any cells on the left and right banks. There's no terminus between channels. It just goes inlet to hydraulic structure to hydraulic structure, hydraulic structure to outlet or out. So I wouldn't consider this a channel that needs to be checked. If you have a really long, wide channel that has a potential for an interior node to be listed incorrectly, or if you have a channel that terminates on the floodplain, you would want to check these nodes. But in this case, we could just ignore them. Chan max, oh, let's see, sorry. So let's see, I'm just saying not applicable. This channel won't have any interior node issues. Plus, it might also be like a good reason to check interior. That's not how you spell that. It would also be a good time to check that if you thought that maybe something was wrong with the way the engine was sorting those or calling those, and that would be a good thing to check. And you could easily import those into QGIS and then just like join them to the grid and then flag them in some manner, like by using like a filter or something like that. Okay, the Chan Bank L and the channel check files. Let's go ahead and review these. So here's our Chan Bank L. Now what we're looking for on this, like this one right here, see how there's a 6-foot difference in the elevation? That would be a flag for me. So let's go ahead and what you'll want to do is just take this and look at anything that's greater than like 5 feet or 6 feet and see why is it that different. So let's go ahead with this one and we will copy it. And you can import this into the QGIS because it has coordinate data. So we'll copy that and we'll come here, put this in here and zoom to that cell. Now, why is that cell so off? First of all, let's turn our cross sections on. So we have a cross section here and a cross section here. Let's grab those two cross sections and see. So I hit this tool right here and I'm just going to grab that cross section and I'm going to plot it. So it goes about 1418, about 1418. And let's go ahead and zoom to that cell again. And let's grab that cell. And let's review that. About 1416, about 1415. Okay, let's get this one. Okay, so that's this one now. and that's about 1415, about 1416 on that side, and about 1415 on that side. So it's a linear interpolation. It's saying that it's 7 feet difference in elevation. Let's see. Let's go ahead and get the grid element elevation on both sides. So if we do this grid element elevation is 1408. This grid element elevation is 1417. So it's perfectly fine. It's just going to bring that elevation up to the bank elevation. That's okay. How about this one over here? This one over here is 1415, same thing. So it's good. It's okay. It just that the grid element elevation was being called by the data down inside the channel. So that one's okay. So you might want to spot check those, but what I like to do with them is I like to sort them and then take anything that's more than 6 feet or 5 feet. Kind of depends on the project, and it kind of depends on what I'm, thinking about or worried about. But anything greater than 5 feet, I'll take everything else out and just delete it. Just get rid of it. And then I'll color things on the map. And so what I'm looking for is a whole line of these that are totally wrong. Like I want to fix a perched channel, or I want to fix a channel that's so wrong that the alignment is totally wrong. There's going to be a big hole in the bank data. So I don't care if the bank is, like in this case, the grid element elevation, let's see, what is it? It's the bank elevation. This is the channel, is 5 feet higher than the floodplain elevation, because when you're on that channel, there's always going to be a change in elevation, and you want these to be reset to the bank elevation. So I don't care about these so much. And as long as I know I have good alignment, and I don't have something like that's like, say I had, for example, my bank was set to, one of my bank elements was set to right here, then I would be concerned. You can kind of see that sometimes this one gets set to like the middle, and then I would be concerned, and I would just move it out. But sometimes, other times, you might have like an entire channel segment is perched. And so then if a channel is perched, meaning that the channel is higher than the floodplain along a whole line, then if the water comes down and tries to flow into the channel, it can't, because it just pond up against those perched banks. So that's kind of what you're looking for. So I'm going to say that this is okay. Well, let's check channel.check. I'm sure it's fine too. And it's empty, so it's fine. So this is okay. Bank elevations are fine. Check. And the channel is empty. Convergence, let's check this out for convergence. I'm not too worried about convergence on this project. It just doesn't really have a convergence issue because it's such a simple project, and the grid element size is 30 by 30, so it's not, yeah, if the file doesn't exist, then you don't have a convergence issue. Yeah, there's no convergence file, so that means that the file is missing. No convergence file is listed. That means there's no convergence issues. If there's a channel convergence.out and you see that 1 or 2 cross sections are listed numerous times, those are problematic cross sections that are failing to converge. So all you have to do is go in and the same checks, okay? Check the slope, check the intersection between the hydraulic structure, check the N value, check the width to depth relationship to the upstream and downstream nodes. And if any of those are too abrupt of an adjustment, then smooth it out a little bit and that should fix it. Or maybe your hydraulic structure rating table isn't quite set up correctly, or maybe you don't have that transition into that hydraulic structure. Those are all things that would cause the channel convergence issues. Super dot out. Let's see if we have any supercells in that channel. So just hit S and see if there's a super dot out. If you don't see a super dot out file, then no supercells were listed. Okay. If there's no super dot out listed, if there is a super dot out, then you want to just review the cross sections or grid at left bank nodes that were listed. And most of the time, those grid elements will have submergence, will have supercritical flow because they might be a drop structure or they might be really steep or something like that. So just review the physical condition. If it's looks like it could go supercritical, then by all means, let it do its thing. Overbank dot out. I don't expect any overbank cells in this file, so if something was listed in an overbank dot out, I would be concerned. You can see that it's empty. Okay. Okay, Chan stability dot out. That's another one that, just like convergence, it kind of help you key in or like hone in on some potential cross sections with stability issues. Again, if you don't see a Chan stability dot out, that means the file doesn't exist. That means there weren't any triggers to cause the writing of that file. So there's nothing to fix. Evacuated Chan dot out, same thing. This one, if you get an evacuated Chan dot out, which we don't have it because there's only one file that starts with E, then again, there's nothing wrong with your channel. That's why I love 30-foot cells. The channel works wonderful. You don't have to worry about it. Okay, the final depth. Check the final depth to see that there's no water left in the channel. Do you need to run the model longer in order for the channel to drain? So that's a good check. Let's go ahead with that. So back up to the Hydrog program, and then you just find the final cross section, and you go upstream 1, and you can see that we have excellent drainage. If that was like way up here or up here, I would expect there to be some problems with this channel, but it's way down here. So that means this project is basically drained. If the bigger your project, the longer you have to run it to get it to drain fully. So just be aware that that is a problem that you will see. Now, when you get your storm drain in here, you're going to check that again once you put your storm drain in, because the storm drain is going to bring water in a lot more slowly. So you do need to be careful about that. Exec area dot out. Just go to X. Okay, this one's pretty easy. You're just going to go flow area. This one is listed in order. Flow area, top width, wetted perimeter. And what am I looking for? Just unreasonable changes in these numbers. If I go up to like 3,000, from 400 to 3,000 back to 400, I don't really want to see that. If it's a nice smooth transition, like this is okay. This isn't too floodplain cross sections, but see how it goes up to it and then back down. So that one's okay. And then at the end, you should expect to see a much bigger channel at the bottom down there, and that's okay too. That we want to see that. So this is good transition. Nothing super fast transition. You know, we're not going from 400 to 1,000. That's what we don't want to see. And the last one was Chan max dot out. So Chan max dot out is way up here. And what am I looking for here? Peak, major change in the peak discharge doesn't make any sense. I'm looking for anomalies, okay? And I don't want to see any flashes of like, you know, 700, 800, 900 cubic feet per second. And the time, I'm also looking for the time. Does the time match what's very close to the peak Q in that hydrograph, or in the hydrograph plus the rainfall? And that's nothing wrong with that file right there. So these are both okay. And okay. No anomalies. I don't even know if I don't even know how to spell anomalies. Well, If it's spelled wrong, it's spelled wrong. And that would be the end of checking a channel. Because this was easy, right? Because there was nothing to fix. If you have to fix a channel, that's called channel troubleshooting, not channel review, right? So if you have to fix a channel, it's always the same, like 3, 4, 5 things that are wrong with the channels. Usually it could be an instability, which means you have to reset your current from something like 0.6 down to something a little bit slower. And the smaller your grid cell size and the steeper your channel, the more you might have to change this down to something a little bit slower or a little bit lower. Got to slow the model down, okay? If you have a lot of drop structures or a lot of, what are those things called? Check dams, they can cause some issues. So what do you do around a check dam? You increase the end value just upstream and downstream of the end value. If you're having problems with a hydraulic structure, the biggest issue with hydraulic structures is that you don't develop this transition into your geometry, into your cross-section geometry. That's the #1 problem with them. Another problem with channels is, so I'll increase the end value leading up to this, increase the end value coming away from it. Just slight increases in end value can resolve a lot of stability issues. In your end value right here, if you're having problems with all your problems are kind of related to your inflow node, just bump this cross section up a little bit. Bump this cross section up a little bit so the water flowing away from this inlet node or inflow node. Also, on that inflow node, if you're having problems with that inflow node and you have a lot of water in it right away because you're putting a base flow in, slow that base flow down and fill the channel a little bit before you start really pushing the water into it. A lot of times with your boundary condition, let's go to our greenway in. A lot of times on your boundary condition, what happens is you're going to give this up to, like, let's say 300-400 CFS and then just let it run and then apply the hydrograph to it. Well, if you bounce that up too high too quickly, it's going to cause instabilities. So just ramp it up over like the course of an hour instead of over the course of, you know, 1/10 of an hour or 0 to the next time step if you're using like 6-minute intervals or whatever. And what's another thing that, oh, and then yeah, just increase the, just add a 1/2 foot to all of these cross sections just so that the water has to flow away from that inlet inflow node. Remember, inflow nodes are sacrificial nodes, okay? So you put them in locations where you can do a little bit of sacrificial stuff to them, like raise them up a little bit to get the water to flow away from it. What else happens in channels? Changes in geometry that are too fast. So for example, that's why I put so many cross sections right here. If you just went from like this to this, that would be a weird change in geometry. It might be too fast. The biggest problem with channels is using a grid cell size that's too small. So if you have a nice big channel like this that has the potential for 5 to 10,000 cubic feet per second, this one probably has the potential to 5 to 7,000 cubic feet per second would be my guess. And if you have that much water flowing through your system and it's really slowing things down or causing the time step to slow down, you should also realize that you might also get some instabilities. If you have a backwater condition, you might see some instabilities. So these are all things that you can, just want the grids or the time step to be a little bit slower so that it has more time to, or it has less water to transfer to the downstream direction and it deposits it a little closer, so that the water that hits this cross section and the calculation time for it to hit inside this cross section are accurate based on the time step. I don't know of anything else wrong with channels. Oh, when you get to your overbank flow, and if you have a really small grid system and you start getting overbank flow, you might see that you start getting some instabilities with the channel as soon as the water starts to overtop. So definitely want to, in that case, you definitely want to increase the end values. The grid elements, the bank elements probably already going to be automatically increased, but if you got like build 19 or older, build 18, build 16, you might want to just bump the end values up on these grid elements that are on the banks. All right, well, that's basically it. I'm going to go ahead and stop the video now because that's it for the channel review video. I will save this and upload it to the tutorial. And let's see, this will be run the simulation, and the video will go here, and I can pop that Excel file right here so you can get it and review it too. Thank you.